Okay, we're back, and Evan is whining because he has no other guys in the room at the moment. It's limiting him, he says. So you all should feel sorry for him. All right, so back at the ranch, how do we find that direction? I need to find this angle up here in the top right corner. I know the side which is opposite, and I know the side which is adjacent, so I would be using what? Tangent again. Tangent of this unknown angle, I'm just going to call it angle A, would be 76 over 90. And then to get that angle, I am going to punch what in my calculator? This is also going to be inverse tangent again of 76 over 90 because I need to find an angle. And once again, for some reason, I don't have the answer in my notes. What was that? 40 even? Really? Okay, but it's going to round off to 40. Okay, PG. I like it. 40 degrees. All right, now, so you all told me he has to go southwest, which is somewhere between 180 and 270. So 40 can't be my final answer. The question is how much south. I know this little angle in here is 40. But I have to know all the way around from 0. If you started at 0 and went all the way around to that point, how many total degrees is that? Well, we know 0 to the bottom line is 180. If I knew this little angle right in here, I could figure it out. Do I know that little angle in there? Why is it 48? Alternate interior angles again. So yeah, that angle in there, I'm running out of space here, that angle right in there is 48 degrees. So I actually know then that I have 180 degrees to the bottom line, plus 48 more, plus the 40 more we just found. If I add all those up, that will give me my total direction, which will give me 268 degrees. So just barely below 270. Almost going straight west, not quite. So in this case, though, my actual final answer then would be 268 degrees, which I didn't realize I had written down here at the bottom of the screen. Obviously, that was left over from another year. All right, so that's navigation. Yours today aren't too bad. Like I said, this will get way exciting come April. I love those things. All right, last but not least, special angles. They're putting their heads down and wrinkling their faces. Oh no, why? You all remember the special angle table? Yeah, you have to memorize this thing now. You're all right. Okay. We actually could get all these values off of, if you remember, the special right triangles you learned in geometry, the 30, 60, 90, the 45, 45, 90. But we actually discovered last year there's a much quicker way to know these values without having to draw out triangles every time. There's a pattern to filling in this table. Anybody remember the pattern to the sign column? It's the key to everything. I'll give you a hint. It starts with, better get a color we can see, square root of 0 over 2. Anybody remember what it does after that? It goes up 1. Square root of 1 over 2. So what's the next one going to be? So I went 0, 1, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. You just have to make the number in the numerator go up 1 every time. Now, several of these will simplify down to something easier, and we do need to simplify them down. You aren't going to want to write square root of 0 over 2. What's square root of 0 over 2 actually simplify to? 0. So that's really just 0. Square root of 1 is really just 1, so you really just have a half. Square root of 2 and square root of 3 don't break down, so those two you're stuck with. But square root of 4 down here on 90 degrees, 2 over 2 is really just 1. So you got 0, 1 half, square root of 2 over 2, square root of 3 over 2, 1. So what that's telling you then, if I say what's the sine of 60 degrees, you all tell me the sine of 60 degrees is square root of 3 over 2. You just have to see it in the table. Okay, now, cosine column is easy if you know the sine column. They go in reverse, yes. You start with 0 on the bottom, you just write them in reverse order. 1 half, square root of 2 over 2, square root of 3 over 2, 1. Now, why does that work? Because of those complementary functions we just learned back at the beginning of this lesson. Sine of 0, its complementary angle would be 90, so sine of 0 degrees is the same thing as the cosine of 90 degrees. Sine of 30 is a half, so cosine of its complementary angle 60 is a half. So it's just doing the complementary angles, that's all you're doing. All right, last but not least, do you remember how you get tangent? Easiest way right now for me to convince you of this is, we know from Stick Your Rotten Crazy xylophone that sine is y over r, cosine is x over r. So when you want tangent, which is y over x, you need the numerator out of sine and the numerator out of cosine. So all you're going to do is you're going to pull, in this case, sine is 0, cosine is 1. That's not a very good example. On the next one, take the numerators. The top of 30 degrees, we get a 1. The top of the cosine is a square root of 3. So you get 1 over square root of 3, which they will rationalize to become square root of 3 over 3. 45 degrees, if you take square root of 2 off the top of each one of them, what will you reduce to? 1. 60 degrees, you take the square root of 3 and the 1, so it's just square root of 3. And last but not least, on the 90 degrees, you can use the square root of 4 or you can use the 1, doesn't matter, because what do you get when you divide by 0? It is undefined. So the tangent of 90 degrees is an undefined value. So I'm going to ask you for things like, hey guys, what's the sine of 45 degrees? You're going to read the table and tell me sine of 45 degrees is what? Square root of 2 over 2. And if I ask you for the tangent of 60 degrees, you're going to tell me it's square root of 3. All right. What about if I tell you I want you to find me the secant of 30 degrees? How do you do secant? It's not up here. It's the reciprocal of cosine. So if you want secant, you just take cosine and flip it over. If you want cosecant, you're going to flip over sine. And if you want cotangent, you're going to flip over tangent. So if we look up the secant, or the cosine of 30 here, cosine of 30 is square root of 3 over 2. So we're simply going to flip it upside down and have 2 over square root of 3. They're not going to let you leave it that way. So you will have to rationalize it. And you'll end up with 2 times the square root of 3 over 3. Does that kind of ring a bell? Okay. Now, here's the kicker. These angles are only in the first quadrant, 0, 30, 45, 60, 90. What about angles in other quadrants? How did we do it? Well, it's not exactly multiples. Let's pick a fun, exciting angle. Suppose I want to do the cosine of 225 degrees. Okay. You are going to draw a picture. There will be pictures on your worksheet. You're going to go cosine of 225. Where is 225? Which quadrant? Okay, we're back, by the way, we're back to normal. 0, 90, 180, 270. We're back to normal. So quadrant 3. Okay, you're going to draw a triangle, and you always draw the triangle upward to the x-axis. Okay. If this angle was 225 and the axis is 180, how many degrees is in between there? 180 to 225 is how many degrees? It's 45. So therefore, you know the cosine of 225 is the same thing as the cosine of 45. 45 is called your reference angle. We used them before. Because it's the angle you use out of the table to get your value. So you would go, hey, cosine of 45 in the table is square root of 2 over 2. Now, there's one other thing you have to check for when you're not in the first quadrant that's going to eat you alive with half points. This is where I could be wealthy. Positive or negative, you have to go check all-star trig class and figure out whether it's positive or negative in that quadrant. So if you look at all-star trig class, in the third quadrant, is cosine positive or negative? It is negative, so you get negative square root of 2 over 2. We got time for one more. Let's do something pizzazzy. I want to do the cosecant of, that would be boring, never mind, I don't want to do cosecant, I want to do cotangent of 300 degrees. Where is 300 degrees? Which quadrant? It's in the fourth quadrant. That's 300 degrees, just stick it out there. You're going to draw your triangle upward to the x-axis, which means it's going up to 360. How many degrees are there, therefore, in between 300 and 360? It's a 60-degree reference angle. So you are going to find the cotangent of 60. Well, if we go to tangent of 60, we get square root of 3. So how do I do cotangent? You got to flip it. So yeah, it'd be 1 over square root of 3, which you're going to have to rationalize. Yep. So you're going to get square root of 3. Now, why did Evan do? Why did you say negative?
What?
I thought you heard you say negative.
I did.
Why did you say negative?
It's not the quadrant.
Yeah. Fourth quadrant, cotangent in the fourth quadrant, it's negative. Okay. I didn't get to show you how to go backwards, so you're only going to do the first 2 pages of your worksheet. The third page I didn't get to show you how to do it in reverse. So just do the top half of page 1 and the top half of page 2.
I'm sorry.
And I will get them to you shortly.
Sorry.